Hi everyone, today in Integrated Math 2 we're going to go over Chapter 8, Lesson 2. Here are the objectives. Make sure you write them down in your notes. Alright, let's go over a parallelogram. A parallelogram is a quadrilateral with both pairs of opposite sides that are parallel. So in our case we have AB, which is parallel to side CD or DC. Then we also have side AD, which is parallel with side BC. We have two pairs. Those are our two pairs. And whenever we're going to be talking about parallelograms, we're talking about this symbol when we write it out. So we have parallelogram A, B, C, D because we have A, B, C, and D. If a quadrilateral is a parallelogram, then the opposite sides are congruent. So in this case, I'm going to show you a quick little example of this. I have these sides. This is parallel and this is parallel. So the sides must be parallel with each other in order for it to be considered a parallelogram. Both opposite sides must be congruent to each other. Then, if a quadrilateral is a parallelogram, then its opposite angles are congruent as well. So once again, I'm going to show you these opposite angles, as you see here. This is opposite of this one. These are congruent, and these are congruent as they are also opposite as well. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. And so we also just showed you that. But what we can also see here is angle X and angle Y would be, when you add them up, they would have to be 180 degrees. In order for it to be a quadrilateral. If a parallelogram has one right angle, then it has four right angles. So if a quadrilateral is a parallelogram, then the diagonals bisect each other. So let's show that as well. Okay, so here's our little parallelogram. And we want to show if we have two diagonals here. And there we go. So as you see here, this line segment is congruent to this line segment. And this line segment is congruent to this line segment. But this line segment and this line segment are not congruent. If a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into two congruent triangles, which we also saw here. We have this triangle, which is the same as this triangle.